Find the time period of simple pendulum of length L, bob of mass m and volume V, oscillate in non-viscous liquid, means we have to ignore the coefficient of viscosity eta, and this density of the liquid is given to us, it is rho. Now first of all, we just displace this bob towards any side by small angle theta, and we write the number of forces acting on the body. I hope it is visible to all of you. Here the force is acting, that is mg, weight in downward direction, and there is one more force will act in the vertical upward direction. This force is known as a buoyancy force. This is the weight of the displaced fluid. Okay. Now, these two forces are acting, one in the upward direction, another is in the downward direction. It means, if we say what is the net force acting in downward direction, we will say net force acting in the downward direction is given by mg minus v rho g. And if I say this angle is theta, of course this will be also theta. And if the restoring force we will calculate, it is given by mg minus v rho g into sine theta. This is the restoring force. So F restoring in this situation is written as negative mg minus v rho g into sine theta. We put the value of the theta, because sine theta, when it is small, it can be taken as a theta. In the next step we will write it is minus mg minus v rho g, sine theta is theta, so it is written as the minus mg minus v rho g. Theta is known as the arc upon radius. If I say this is x, length is given as L, so it is given by x upon L. I hope it is clear. Now what is the acceleration acting on the system? Acceleration is given by F by m. So we calculate minus g minus v rho g upon m into x by L. We compare with the standard equation, that is A equal to minus omega square x. We will get the value of the omega, that is root g minus v rho g upon m upon L. We put the t equal to 2 pi by omega. It is given by 2 pi root L upon g minus v rho g upon m. So right answer of this problem will be 2 pi root L upon g minus v rho g by m.